For this project, the main objective is to understand how electric vehicles are positioned in the market based on their technical, economic, and manufacturing characteristics. Instead of looking at a single factor such as price or driving range, the study treats for EVs as an integrated product where performance, technology, and cost interact with each other. By using the dataset include the battery capacity, range, pricing, safety rating, autonomous levels, charging system, country for manufacturers, and 2024 sales. The study aimed to develop a clear picture for how EVs compete in the market and how consumers may respond to different product configuration. More especially, the study focused on several key questions. First, it examined how EVs are differentiated in the markets, whether through the performance, technology, or safety-oriented desire. Second, it looked at whether high prices are consistently linked to better technical performance or whether branding and manufacturing orange also play an important role. Third, since the datasets include the sales for 2024, the study explored which vehicles attribute appearance most relevant to market adoption, such as affordability, range, safety, or charging convenience. Finally, the research aimed to identify the meaningful market segments based on the actual data rather than the assumed labels, and connect the individual vehicles' features with the boarding trend in the EV industry.
Data preprocessing involves the profiling, cleansing, validation, and transformation to prepare the raw data for analysis. If the dataset is low quality, it can impair the subsequent analysis result and lead to the misleading conclusion. Therefore, preprocessing is crucial for identifying and improve the data quality before any analytic work is performed. The data of this study is obtained from the Kaggle using a dataset focused on electric vehicles. The dataset includes both quantitative and qualitative variables. Quantitative data cover the numerical attributes such as the price, driving range, battery capacity, while qualitative data consists of category attributes such as the vehicle brand, model, and the type. This dataset was chosen because it provides a well-structured and comprehensive overview of EV characteristics that align close with the study objective. To the data cleaning part, the data cleaning involves the remove the duplicate record from the dataset. Besides that, the missing or the new value are replaced with 0 when appropriate to maintain the data consistency. The process also including the checking the data quality and detecting the correct data type for each variable.
At the top of the dashboard, we first see the key summary indicators. The total number of electric vehicles sold is around 31 million units, showing strong market growth. The average price is approximately $90,000, and the average driving range is close to 350 kilometers, indicating improvements in both affordability and technology. On the right-hand side of the dashboard, we have several slicers, which allow users to interact with the data. The safety rating slicer lets us filter vehicles based on their safety scores, so we can analyze how safety performance affects sales and pricing. The year slicer allows us to focus on specific time period, such as comparing trends across different years or isolating data for 2024. In addition, the battery type slicer enables us to examine how different battery technologies, such as lithium iron or lead-acid batteries, influence price range and sales performance. These slicers make the dashboard flexible and suitable for deeper analysis. Moving to the charts, the bar chart on the left shows 2024 sales by manufacturer. We can see that major manufacturers experienced steady sales growth, reflecting rising consumer acceptance and increasing competition in the EV market. The slicer plot in the center compares average price and average driving range by manufacturer. Overall, higher price vehicles tend to offer longer driving ranges, but the relationship is not perfectly linear. This suggests that efficiency and battery technology also play a key role, not just the price. Finally, the down chart on the right displays sales distribution by safety rating in 2024. Vehicles with higher safety ratings account for a larger share of total sales, showing that safety is an important factor influencing consumer purchasing decisions.
Dashboard 2 focuses on the technology side of electric vehicle, mainly looking at battery performance and charging method. At the top of the dashboard, different battery types are compared using a bar and line chart. The bar shows battery capacity in kilowatt-hour, while the line shows how far the car can drive on one charge. From the chart, it's clear that lithium-based batteries perform much better than other types, and lithium-ion batteries perform the best, with the highest capacity and the longest driving range. This is why most electric vehicles today use lithium-ion batteries. On the other hand, batteries like lead-acid, aluminum-ion, flow battery perform much worse. This shows that these battery types are either not very developed yet or not practical for everyday passenger electric vehicles. The chart also shows that cars with large batteries usually have a longer driving range, but the relationship is not perfect straight. This is because real driving range depends on other factors too, such as the weight of the car, energy efficiency, and how much power the car uses. In the lower part of the dashboard, we look at charging infrastructure. The chart compared charging time and how many vehicle models support each charging method. We can see that most common charging types, such as Level 1, Level 2, DC fast charging, NACS, and V2L, have similar charging times. This suggests that charging speed is become less of a problem for most users. However, there is a big difference in how many models support each charging method. Charging options like modal charging, Level 1, NACS, and V2L are supported by many vehicles, showing that they are already widely used. In contrast, wireless charging and some advanced charging methods are only supported by a few models, which means that they are still new and not widely adopted. Overall, Dashboard 2 shows that while battery technology is important, market support and charging availability are just as important. Technologies that are widely supported and easy to use tend to be adopted faster than those that are technologically advanced but not yet practical. Dashboard 3 shows the average price of electric vehicle in USD from 2015 to 2025 using the line chart. From the chart, we can see that EV prices do not move in a straight line, instead of only going up or down. The price go up and down over time. This shows that the EV market is very active and changes quite quickly. In the early year, especially around 2015 and 2016, the average price is quite high and even reaches the peak. This is because the EV market was still new at that time. Production costs were high, batteries were expensive, and most EVs were sold as premium product instead of affordable car for everyone. After 2017, there is a clear drop in the average price. This suggests that EVs started to become more affordable. This changes is mainly due to better battery technology, lower production cost, and more car companies in turn to EV market. When more companies compete, price usually go down. Producing EVs on a large scale also help reduce the cost. In the year after that, the price do not keep falling smoothly. Instead, they go up and down. This happened because some manufacturers releases more high-end EV model with longer driving range, better safety features, and smart technology. This premium model pushed the average price up in some year. In recent year, we can see the price slow going down again. This shows that EVs are becoming more affordable overall. Improvement in battery production, shared component, and strong competition have helped reducing price. Overall, dashboard shows that even though EV price fluctuates in the short term, the long-term trend is towards better affordability. At the same time, EV technology continues to improve, making electric vehicle more accessible to a wider group of consumers.
Hello everyone, let me talk about the conclusion. First, many companies sell electric cars, but only a few big brands sell most of the cars. Secondly, higher prices usually mean longer driving range, but some mid-priced cars also have a good range. This shows that good design and efficiency are important. Third, safety matters a lot. Most EVs sold have a high safety ratings, while very few low safety cars are sold. Next, lithium-based batteries perform best. They usually offer a longer range. Finally, charging adoption depends more on charging stations and sport than on charging speed. EV prices were high at first, but they become more affordable after 2017.
Hi everyone, so let's go for last part recommendations. First, for manufacturers, competition should move beyond simply increasing battery size. Instead, the focus should be on range efficiency through improvement in powertrain efficiency, energy management, thermal control, and lightweight design. These strategies allows manufacturers to deliver a strong real-world range at a mid-level price, which better matches mainstream consumer demand. At the same time, safety should be treated as a default value proposition. Since consumers strongly prefer vehicles with higher rating, manufacturers should both invest in safety engineering and communicate safety performance more clearly. Second, charging strategy and ecosystem readiness are critical. Prioritizing mainstream charging standards and capability can significantly reduce charging anxiety and improve users' convenience. For non-leading brand, differentiation is essential. They have to avoid competing directly with the market leader. And finally, from a policy and investment perspective, accelerating charging infrastructure, strengthening standards, and supporting safety transparency will improve overall market quality, while investors should look for efficient challengers alongside established leaders. So that's all for our presentation. Thank you.